Hi everyone. In this video, we're going to just take a look at a common task and then use it to understand how programs flow logically. All right, so here we have a task, and the task is just to create an application that prints out numbers that are prime numbers within a range of numbers. So I want to define a range of numbers and then print out all the numbers within that range of numbers that are prime numbers. And by definition, a prime number is a number that is greater than one and can only wholly be divided by itself without any remainders. All right. So what I want to achieve is I want to look at a range of numbers, say from number 1 to number 50. And then I want to be able to run a piece of code that would tell me, hey, within this range, 1 to 50, these are the prime numbers. So what I'm going to do is I'm going to break down the logical steps that I'm going to take in solving this problem. Now, if you look at these steps closely, you'll discover that they look like the steps that you would take in real life when you're solving this problem. So what I'm going to do first is I'm going to create a range of numbers. I'm going to determine, okay, so what are the numbers that I want to have in this function? And then the upper limit and the lower limit. I'm going to determine that. Then the next thing I'll do is this. I'll pick a number from the range. So let's say I've defined a range from range 1 to 50. I'm going to pick a number, say, let's start from 1, because I mean, I have to test all the numbers in the range. So I'm going to start from 1, or let's say I start from 5. So the first thing I'm going to do is um, I'm going to try to check if that number I picked is greater than 1. Obviously, when you're having a follow-up or when you're having a decision like this one, you have to take the numbers chronologically, all right? So the first number that I will take this time is 1, all right? But I could take any number, 5, 10, but just to, make this stuff very explanatory, I'm going to just take the first number 1. So the first thing I'm going to do is I'm going to create a decision variable that, like a decision flow, not variable, that asks the question, is this number greater than 1? So if the number is not greater than 1, then it can be a prime number because by definition, a prime number is a number greater than 1, right? But if the number is greater than 1, then I proceed to the next step. And with this number that I've selected, again, which could be any number, but we have to go chronologically. I'm going to divide that number through every other number beginning at the number 2. So let's say I pick a number 10. I check this first decision point. Is this number greater than 1? 10 is greater than 1, obviously. So yeah, that passes the first test. The second test is now I begin to divide 10 with all the other numbers before 10. 9, let's start from 1. 10 divided by 1, 10 divided by 2, 10 divided by 3, 4, 5, 6, 7, 8. But in this case, because 10 divided by 1 will leave no remainder, then I really do not want to use that because it's going to mess up my code. So what I'm going to do is I'm going to start from 2. I'm going to say 10 divided by 2, all right? 10 divided by 2, 10 divided by 3, then 10 divided by 4, 10 divided by 5, until I get to 9. I'm not going to get to 10 because if I do 10 divided by 10, obviously, I'm going to get a 0, right? So already that would give us a null value and we will not get the answer right. So I'm just going to start from 10 and I'm going to go up to 9. And then I'm going to, if that value does not find a divisor that divides it wholly without any remainders, then that's a prime number. But if there's any number that divides it wholly, then it's not a prime number. So let's put this into code and then let's see how it works. So the first thing I'm going to do is usually when you want to do stuff like this in Python, you want to define it as a function so that it makes the code modular and then you can, call it from anywhere that you want to call it inside another piece of code or even as an API into another module, right? So that's why it's advisable whenever you're creating a task like this, usually create it as a function. So let's call this function get primes, right? Okay, so now as usual, the first step is to create the range of numbers. So the range of numbers, I'm going to call it lower and I'm going to call it upper. So the next thing I'm going to do is I'm going to say, let's pick a number in the range. Remember, from this range, let's say number 1 to 50, then we're going to pick starting from 1. It's going to run all of these steps on that number 1 you pick, and then it goes to the next number 2, it runs all the steps like that. So let's put, whenever you have to run steps like that, iteration, obviously, I know where your mind is going, a for loop, and you're correct. So let's put a for loop here to say for each number that I like to use this num here. But as you know, it's a throwaway variable you can use for I, for J, for anything you like. But I'll just use the num here so that it makes everything clear. So for num in range, lower and upper, I'm sure you know that the range function accepts the 2 bounds. So, but there's something I must remind you about the range function. Before I come back, let me just quickly do this, lest I forget. So if I put this, let's say for I in range 1 and say 3, and I tell Python print I, this is what's going to happen. It's something, it's not weird, but it's something that comes with Python. Python is going to leave out 1 in this place, all right? And I think it has to do with the zero-based indexing Python has. So it's looking at what's in the range here from 1 to 3. It drops out the last one. So if I want to include 3, I have to add 1 here. So then I'll have 1, 2, 3, all right? So that's why in this case, I'm going to do this for num in range lower and upper plus 1 because I want to add that extra 1. What should I do? The next thing I want to evaluate is this, based on this step number 3, the decision. So I want to find out, is this num greater than 1? And remember, this num is what exists between lower and upper. So let's say if num is greater than 1. If it passes this test, then what do we want to do? We'll pick that num and then start dividing it from every number beginning from 2, like I explained earlier. So let's start dividing it from every number beginning from 2. So we'll now say for I, which is every number. You can use anything here. You could say for every number or whatever it is, but let me just use I here. For I in range beginning from 2, because I told you if you use number 1, obviously any number divided by 1 doesn't leave a remainder, so it spoils the calculation you're trying to do. So up to num. Now someone is going to ask me, why did you not do num plus 1? The reason is that if I do num plus 1 like I showed you here, I will include that number at the upper limit. And the moment I run that number divided by itself, it's going to give me a 0. So it's going to cancel everything that I'm doing. That's why I'm not going to put num plus 1 this time, all right? So because like I explained, if I want to use number 10 to evaluate this function, I don't want 10 to divide 10. I want 10 to divide 9, all right? And that's one of the beautiful things about this, in quotes, what looks like a bug in Python. So here I'm going to proceed and I'm going to say, so for each of the numbers there, what should Python do? If that number divides I and there is no remainder, that's what this is just saying. If this is the modulo function and it's just saying, hey, if you divide this by this and there's no remainder, then break. Break means just exit the loop, all right? Exit the loop. And at this point, it just makes sense that, okay, let's just stop what we're doing. But remember, there has to be a converse. There has to be an other side of this thing. And somebody would ask me again, if we put else here, what would happen? Now, this is what will happen. I'm going to drop the Python documentation that would explain this very well as part of the link to this video. So you can check in the description of this video and you see the link to the Python documentation. So what happens is this. Whenever there is a for loop, all right, and there is a break in the for loop, when you want to exit the for loop, you have to use an else. Now, I know you must have been told, hey, if else, they all go together at all times. Yeah. And if you've been following a series, I've shown you that if can exist on its own, else also can exist on its own. So this else you see here is more like the else that exists on its own as part of maybe a try except else block or something. All right. So if I don't do this, if I put this here, I'm not going to get any result at all. All right. But if I put this here, it's going to compensate for this break that is here inside of this for loop. Because a for loop, when it encounters a break, it doesn't know where to go to next, right? So that's why we put this else here to just say, hey, when you encounter a break, don't bother. This is what you should do next, all right? So what should I do next? That's what I'm going to tell Python, print num. All right. So now I'm just going to run this. So that's, yeah, cool. And let's call this function get primes. So let's say get primes. And let's put number 1 and number 30. All right. So when I run this, it's going to give me all the prime numbers between 1 and 30. All right. Now, if you're using VS Code and you're not using a Jupyter notebook, you're using a .py file, sometimes there might be the temptation to use the print statement. If you put a print statement in front of this function when you run it, you're going to get an addition, and that addition is a none. And why are you getting this? Very simple, because already your function contains a print statement. So if you put another print statement here, it's going to evaluate and tell you none, because I mean, yeah, you have two print statements there. So that's basically how to solve problems in Python. It begins with you trying to understand how you would solve that problem in real life, and then try to use the shortest routes, to instruct the computer on how to go about that problem, just like you do it in real life. So see you next video. Bye.